We were approached by the ESR forensic scientists who are the experts in blood spatter to develop a skin skull brain model for them to study these mechanisms from ballistic impact. And as dentists or in the dental fraternity, we make maxillofacial prostheses, that's ears, eyes, noses, half faces, using simulant materials like silicones and acrylics and plastics. And they mimic those human tissues. So that was why they approached us, because we are the experts in the head and neck. And that was successful, and they were very pleased with what we did. And then in conversation with our maxillofacial surgeons, Professor Darryl Tong, we then said, could we adapt this forensic head model to study subconcussive brain injury? And that's how we got into this phase of it. So why are dentists or people in the dental sector looking at this? It's that ability to make any prosthesis for the body out of a simulant material that enables us to now produce this. And of course, oral maxillofacial surgeons put people back together in terms of that sort of head and neck area, so they're familiar with that whole side as well. We had to first validate the different human tissues in terms of our simulant materials. So human brain, it's what we call anisotropic. In other words, the structures of the brain, they've got little fibers, etc. So we can't produce a human brain. It's not possible. But what we can do is produce a material that's got similar properties to that. So we looked at gelatin initially and found that was too elastic. And so we've done a series of experiments of different combinations of materials, and now we've come up with what is an agar glycerol water mixture, and that mimics the human brain. So we've gone through a process of validating the different simulant materials. We did the same with the skull, for the bone of the skull, and likewise for the skin. And then with those materials that we've now validated, we've put it together in the form of an anatomical head. And then into that we've embedded accelerometers from on top of the skin, under the skin, on top of the skull, under the skull, top of the brain, middle of the brain, and the base of the brain. So all of this is one under the other, and we can then impact that site and then measure the energy transferring down through to the base of the brain. We have anecdotally now rugby players in New Zealand in their sort of 40s and 50s showing signs of early onset of brain damage, like dementia, things like that. And we do know that concussion, regular concussion or impacts to the head leads to brain problems. And we see that in Muhammad Ali, an example of a professional boxer over time. We also know from the American, what they call American football system, we know from New Zealand rugby, that injury to the head can cause brain damage. So what's the unknown factor at the moment is what is the cumulative effect of the subconcussive impacts long term. And because we have no data on that, we've got very little data on that, we are trying to study that. And if we can get an understanding of that, we would like to take it to the stage where with what we do, we could then miniaturize the point where we could embed sensors into, for example, the scrum cap of a lock forward, and in real time then start to measure on the field what sort of impacts or what's going on there. And so the significance is that if we can understand it and understand these mechanisms, we can then start to put in place either design of headwear to protect. Having said that, it didn't seem to work in the American football system, where because of helmets they were using their heads to tackle with their head. Whereas in rugby, because you don't have a helmet, you tend to keep your head out of the way. But we could start to understand things, and maybe that would result in rule changes or better treatments. Protection devices. And it's not just in rugby, it applies to any sort of contact sports, industrial place type safety. So it's got a very wide application once we can get the understanding of what's going on. What we would like to do once we publish our results, it's very important that each stage that we go along, we publish into the peer-reviewed arena of science, because that validates that what you're doing is valid. So we will publish, and then with that we would then look to approach someone like New Zealand Rugby Football Union, or maybe the American sort of NFL, or NFL? Anyway, the American football system, to get larger funding, where we could then look to start developing miniaturization, which we could put onto players and measure in real time. And then that would then in turn lead ultimately to protection, design of protection for players, as well as sort of a deeper understanding from the medical point of view of what are these thresholds. So it's got long-term, very profound implications. This data that we're going to be getting from this, it will lead to improvement in safety for players, improvement in safety for people in the workplace, things like that long term.